Nice day, y'all. It's me, Pepin Joseph Endorla, your buddy in math for today. And I am here to talk about the geometric sequence. I'll be discussing what the geometric sequence is, how to find the next term, what is a common ratio, what's the nth term, and finding the sum of all terms. Okay, let's immediately go on. With our example here, 9, 18, 36, a geometric sequence is a sequence with a common ratio, as you can see over here, common ratio. To find a common ratio, it's when you divide 18 with 9, or this term with this term, and the term before it. So 18 divided by 9 is 2. 36 divided by 18 is 2. Now, as we can see here, 2 is our common ratio since these two are the same. To find the next term in the sequence, you multiply 36 by our 2, by the common ratio. And that common ratio happens to be 2. So 36 times 2 is 72. And 72 times 144, 72 times 2 is 144. It's quite simple. So, another example I have right here is 500, 250, and 125. Now, this example is different to the example I just gave, the 9, 18, 36, because with this sequence, it's descending, while this other one is ascending. But the rules still apply the same, except for one. 250 divided by 500 is 0.5 or 1/2. This is also 1/2. Now, to find the next term, since this is descending, you would, instead of multiplying, for example here 72 times 2 is 144, you would divide. So 125 divided by 1/2 is equal to 62.5. And then the next number, 62.5 divided by 1/2 is 31.25. So, what I can say here is that for sequences that are descending, you divide. For sequences that that ascend, you multiply. Okay, now we're done with finding the next term and what a common ratio is. Now, let's go to finding the nth term. In both finding the nth term and the sum of all terms, right here, there is a formula to make finding those missing terms easy. I'll be using the same example since it's easier that way. Okay, so let's say 9, 18, 36, find the 15th term. Okay, so now this is the formula for finding the nth term. It's a sub n is equal to a sub 1 times r raised to the power of n minus 1. First, an a sub n is the 15th term that we're looking for. A sub 1 is the first term in our sequence. Since 9 is our first term, we put 9 here. N is R is our common ratio, and from our past example, we know that the common ratio in 9, 18, 36 is 2. Okay, N is this 15 right here. So 15 minus 1. 2 raised to the power of 14, since 15 minus 1 is 14. Let's check that right now with our calculator in the other tab. So that's 2. 2 raised to the power of 14 equals to 16,384. 16,384. Okay, now our final step in this example is 9 times 16 times 384, which is 147, 456. That's our ace of 15. Our ace of 15 is the 15th term in this sequence. Simple as that. Okay, let's have another example. Copy this for reference, by the way. Anyone watching? Underline this, okay? Another example is 2, 4, 8. Simple. Common ratio, easy. 2 again. But find the 20th term. 21st term. Okay, so with this formula right here, ace of 1 is 2, common ratio is also 2, the n is 21 minus 1. 21 minus 1 is just 20. Let's check here with our calculator. 2 raised to the power of 20. 2 raised to the power of 20 is 1,048,576. 1,048,576. Now remember, we still have to multiply that. So times 2 is equal to 2,097,152. That's our ace of 21, or the 21st term in the sequence. Okay, now that we're done with the finding of the nth term, now we're gonna move on to the sum of all terms. I'll use the same example as earlier. How about find the sum of all terms. Until the 18th term. Now, I'll be showing you the formula for the sum of all terms now, which is S of n is equal to a sub 1 times 1 minus r raised to the power of n divided by, this is n, 1 minus r. That's our formula. Copy this. And now we'll be using it in finding the 18th term. First term is 9 times 1 minus common ratio is 2 and 18. 1 minus 2. 18 raised to the power 2 raised to the power of 18 is 262,000 262,144. Let's just do this quickly, which is negative 1. Simple as that. The next number, the next thing we need to do is 1 minus 262,144. So that's just negative 262,143. And then we multiply 9 times negative 262,143 equal to negative 2,359,000 negative 2,359,287. Negative 1. Okay, so now we just divide this, and our answer would be 2,359,287. That's our sum of all terms till the 18th term for this sequence. Nice. It's as easy as that really for the sequences, and that's about it. We discussed the geometric sequence, the finding the common ratio, finding the next term, finding the nth term, and finding the sum of all terms. That's it for me today, and